All right, Algebra 2, Day 6 notes. We're dividing polynomials with long division. Probably the most important topic of the entire unit. Just like you did in elementary school. Can you just still do long division without a calculator? All right, give it a shot. You'll be fine probably. Remember your answer is up here is 24, right? The quotient. That's the same as 12 times 24 is 288. Don't forget your basics. And we're going to expand that into polynomials though. It's a little bit different. All right, a few things you want to try to do. All right, I'm just giving the answer here, obviously. You're dividing by x plus 6. Forget the plus 6. X times what gives you 2x squared? That's 2x. Multiply 2x by everything out front. That's what comes down here. All right, you want the first term to cancel. The rest of it does not need to cancel. All right, process starts all over. X times what gives you 3x? That's 3. 3 times everything out front comes down here. Just like you do up here, you subtract the line below, you're going to subtract everything here. All right, so distribute that negative sign to everything. Remainder 0. All right, we'll do some examples in a second here. Number 5 and 6, just like the one on the front. Pretty straightforward once you know what you're doing. Those ones probably too easy for you guys once you know what you're doing because there's remainders of 0 every time. All right, a lot of people don't realize it yet, but if you take like number 5, for example, I'm just gonna rewrite it up here. All right, x squared plus 7x plus 12. Forget all this long division, let's just factor that. What does that factor out to be? X and x. Factors of 12 to get you a 7. That'd be 4 and 3, right? So if you were to actually go back to the question and say it's division by x plus 3, your answer, x plus 4. It's just factoring, that's all it is. All right, so 5 and 6, pretty straightforward. Number 7, going back to your elementary days, has a remainder though, right? Remainder of 3. That's great. We don't write remainders anymore though. You're gonna see a bunch of different letters, a plus b over c form, something like that. Same idea. Divide this polynomial by x plus 6, you get a remainder of 2. All right, different ways of writing your answer. They call it q of x plus r over a form, quotient remainder form. There's a bunch of different fancy names for it. We'll do some examples in a second. Here's number 11, all done for you. Remainder is 10. So your quotient is x plus 5. The remainder is 10. X minus 3 is what you're dividing by. Just a fancy way to write your answer is all it is. All right, let's do 13 together. All right, 13, we're gonna do long division. Got a long polynomial. X cubed plus 7x squared plus 17x plus 41 divided by x plus 5. First thing, forget the plus 5 for a second. Just think x. X times what gives you x cubed? That's got to be x squared. All right, and now x squared times everything out here. Think about it, there's parentheses there almost. X squared times x is x cubed. X squared times 5 is 5x squared. All right, you're going to subtract that line. So do whatever you need to do to make it work. Don't forget to distribute that negative sign if you write it like this. X cubed minus x cubed, that should always go away. 7x squared minus 5x squared is 2x squared. Bring down the 17x. Start the process all over again. Forget the plus 5 for a second. X times what gives you 2x squared? It's got to be 2x. All right, now 2x times all of this is 2x squared plus 10x. Subtract that line. First term's got to go away. 17x minus 10x is 7x. Bring down the 41. Start the process all over. x times what is 7x? It's got to be plus 7. All right, 7 times all of this is 7x plus 35. Subtract all of that from the line above. First term gone. 41 minus 35 is, what's that, 6. All right, you know you can't go any further because x times nothing will give you 6. So that's as far as it goes. All right, fancy way to write your answer if you want to squeeze that in there. X squared plus 2x plus 7 plus the remainder over what you divided by. There's number 13. 14, same idea, more of it. Answer's down here. 15's got a little twist to it. Let's look at 15. We'll do this one together. 15, if you notice, it's x cubed minus 2x squared plus 3. All right, when you're doing long division, there is no x term, so you actually want to throw a 0x in there. Make it easier for yourself. All right, it's like a placeholder. All right, same process though. All right, forget the plus 1. X times what gives you x cubed? It's got to be x squared. X squared times everything. X cubed plus x squared. You're subtracting this whole line. Oops. Simplify. X cubed minus x cubed is gone. Negative 2x squared minus x squared is minus 3x squared. Bring down the 0x. Start the process all over. X times what gives you negative 3x squared? Gotta be negative 3x. Negative 3x times everything. Negative 3x squared minus 3x. But you're subtracting that entire line. That's where everyone makes mistakes, all right? Little things. Distribute that negative. Negative 3x squared minus a negative 3x squared goes away. 0x minus a negative 3x is positive 3x. Bring down that plus 3. Running out of room. Start the process all over one more time. X times what gives you 3x? It's got to be 3. All right, so 3 times everything out front is 3x plus 3. If you subtract that whole line, nothing left. Remainder is 0. All right, so your answer works out to be just this, x squared minus 3x plus 3. All right. A little bit challenging. Once you get some practice down, get used to it, it's not too bad, hopefully.